Okay, let's go further with example of illustration of ideal final result concept application for creative design. And the next example is a little bit more scientific. You know, we try to migrate from very simple examples to more and more scientific, more, let's say, physically or mathematically involved, to show you the real way it works. Another standard problem that started, you know, as a kind of toys in ancient time, but became very technical and very important in the time of Industrial Revolution, was to make it possible to control rotation of something at the required rate. So the idea was simple. When the first steam machine appeared, you know, it was in the United Kingdom, obviously maybe 300 years ago, like this. First steam machine appeared, a steam turbine, if you want. It was necessary to somehow to make sure that it rotates at the required rate, because otherwise machine could work not in the way it was supposed to work. And there was first invention came, and invention was very bright. It was famous invention, and actually the symbol of this invention became a symbol of automatic control theory. This kind of governor, a governor of Watt, of James Watt. And the idea was very simple. Because of centrifugal force, there are two big masses, you know, somehow sitting on the rotating shaft. When the rotation speed was high, they went like this because of centrifugal force, and because of this kind of link, mechanical link, they could stop, or sorry, they could close or open the valve to supply the steam to the turbine. Okay, so when it rotated too fast, it went like this way, and because of the link, the valve was closed. And when rotation was too slow, then they went a bit like this way, and they opened up, and then more steam came. Brilliant invention. Actually, they used a similar invention to control the windmills a little bit earlier, but it's another story. It is invention. It is itself. You see, no sensor, no operator again, so it is very nice invention. Not obvious, by the way, but the problem appeared later. Sooner or later, well, actually in a couple of decades, they realized that sometimes the machine behaves really nasty way. So it's like, let us assume that required rotational rate was like 50 Hertz, so 50 rotation per second, maybe pretty high, but okay, let it be 50 rotation per second. But the machine started like kind of deviation, like 51, 49, 52, 46, 50, 59, 40, and so on, and it ended up with a kind of stop or a kind of even blast sometimes. Yeah, it was unstable. And again, they had to understand what is going on. And what I really love about science, that they make a model of it. Two famous scientists. One was famous Maxwell, you know, who developed electromagnetic theory, the theory of electromagnetic waves also. And another was Russian scientist Vishnegradsky, who independently developed a theory, a model, and explained why it happened. And in the next slide, there are modified Watt governors, and there were also inventions, but they were based on analysis of differential equation. And again, it made it possible to govern the system itself, but you never would understand how it is possible to do unless you know differential equations. Again, you see, ideally we introduce a system that would govern the steam turbine rotation at certain rate, and we succeeded in it. Ideally, we correct it a little bit in such a way it's still stable. And this is a very nice example of, let's say, of coming together invention, science. And science helps inventors to design something that is ideal, that operates itself, very simple.